Greetings, everyone. My name is Pavel Hayek, and I will be talking about the outputs of challenge number 8 and 7 of the Agrihub Inspire Hackathon 2022. The introduction goes first, so the goals of the challenge number 8 and 7 will be stated. Challenge number 8 was meant to enhance the established second version of the Open Land Use database with different thematic datasets from different regions. While the goal of the challenge number 7 was to improve the second version of the Open Land Use map for Africa. So that's why we cooperate very closely together. Few words about the methodology and open land use itself. It's a seamless, harmonized, vector-based database focused not only on land use or land covered topics, but it integrates a lot of different thematic datasets and layers as well. But it integrates the most detailed geometry which is available for the particular area from the perspective not only of the geometry itself, but the amount and values of attributes as well. Firstly, it was presented in 2013 as its first version, and the ongoing second version has been started in 2019. And now to the results of the hackathon from these two challenges. First results will be shown on the first pilot we had, which is the Rostince farm in the Czech Republic, Central Europe. And because it's in the Central Europe and particularly in the Czech Republic, we have already had a lot of different topics and themes incorporated in Open Land Use database and its second version already, as you can see here or there, because we have a lot of data available on our area, our mean Czech Republic. But newly, during this hackathon, we added selected attributes from soil grids dataset, which is worldwide dataset. And firstly, I will show you the results from this area. The land use and land cover from this area looks like this, and this is the current version of the open land use on this very particular area. While we added several topics and about the soil itself, for example, this organic carbon stocks in soil, while the more reddish color means there is a higher density of the stocks in soil surface layer for this particular area derived from the soil grid dataset. And similar dataset or data from this dataset is dealing with nitrogen in soil. So this is the same area which represents the total nitrogen in soil surface layer, also with the red color. But we face the issue when we have a lot of data sets, very detailed one, rich in attributes, for example, in Europe, generally speaking, but not in all areas of the habited world, I would say. So during this hackathon, we proposed and in the report described a new approach for enhancing the second version of the Open Land Use database, which is based on world-covered data set from European Space Agency covering the whole world, and a combination of this raster dataset with OpenStreetMap dataset and the delimitation of features on the ground, which is available in this dataset. tested this new approach in China, in pilot sites of the CSO project, and in particular parts of Africa. These are 4 pilots of the CSO project located in China. And we used this approach when we combined open land use or OpenStreetMap with the world cover dataset into the OLU database, while we had to convert the raster dataset of the world cover dataset into the vector form and combine it with the vector form of the OpenStreetMap. And on top of that, enhance these areas, delimitation of the ground with different topics. And one of the topics was related with the soil, the same way as the previous example from Rustinitz. So this is, for example, pH in the vicinity of the pilot number 10. In China, this is different data about the soil from different area of the pilot number 8, 9, and this is the one from pilot number 8. And it goes forward with the 4th pilot. Nevertheless, the African example is a little bit more interesting from my side, because this what you see is the first version of open land use for Africa, which has been established or had been established in 2018 during a hackathon as well, based on the data from Africover dataset with a resolution of 30 meters. And this is the result. 1 year later, the previous year, during the Open Spring Hackathon, we used the OpenStreetMap database and combined this OpenStreetMap with CCI land cover dataset, which has 20 meters resolution, into the form of OLU4Africa version 2. Nevertheless, we wanted to make it better, so we used the ESA world cover dataset with 10 meters resolution as well. And in this slide, you can see the examples from the second version of OLU4Africa dealing with unsupervised classification of data from Sentinel-1 and 2 in order to create or retrieve the information about land use, the particle area or land cover. And it led to this example from Senegal and Gambia, while this what you can see is the second version of open land use for Africa. And now we combine it with the data from ESA world cover. And as you can see, the level of detail is much better. So we wanted to enhance this OLU4Africa, the second version, into, let's call it 2.5 version. And we tested it on relatively small areas, for example, here on the border of Kenya and Uganda, while we performed some tests with unsupervised classification from Sentinel data from this particular area as well. But this has not been yet evaluated, so that's why there are no pie charts represented here. But we can go to the findings and conclusions right now to wrap up and sum up the outputs from the challenges number 8 and 7. While what you saw is publicly available as map and compositions with the open land use, either or the open land use database itself, or the particle part of the open land use for Africa. And you can search for the compositions via these links on the digital innovation hubs of Hub for Everybody, the Smart Agrihub, and the Sea Soil itself. And in the bullet points in this list, there are the names of the compositions available there. You can find them easily. While in the report from this hackathon for these challenges is described how to find them. Nevertheless, we have proven that the open land use database can be enhanced or enlarged easily with different data sets, with different topics from different areas. And we proposed a method how to retrieve so-called OLU objects based on the European Space Agency WorldCover dataset in combination with OpenStreetMap dataset in order to create an open land use for a particular area where there is no feasible dataset available from a local provider. And we tested this approach on the area from the Czech Republic, from China, and from Africa as well. And we found out that we had some issues in merging these two datasets of WorldCover dataset and OpenStreetMap together. So for the further steps, we have to improve the algorithm for generating all objects from WorldCover and OSM. And on the other hand, we have to get into the better availability, fluentness, and speed of the providing web map services or web feature services from the database, because as we see, we are extending rapidly from a perspective of the area incorporated in the second version of the OLU database. So we have to deal with a higher traffic or a higher amount of data to be transferred from the database to a user. So that's another issue we have to deal with in the future. And we would like to incorporate more types of data, for example, from sensors, from Earth observation sensors, from IoT, and so on. And that's all from my side for now. Thank you for watching. And if you have any questions, you can email us. Thanks for watching once again.